Hello viewers, tutorial 12 question 2, work out the following integrals. So if we look at the kind of function that we're integrating here, first one is t plus 1 to the power of 4. If we were differentiating that, we would differentiate it using the chain rule. So naturally enough, we're going to integrate using the reverse chain rule, which really amounts to a guess and check method. So we're going to make an educated guess as to what the integral could be, and then we're going to differentiate our guess to check whether it's correct. And we're using the fact that integration is the reverse process of differentiation. So if we were to integrate t plus 1 to the power of 4, well, let's think about if it was just t to the power of 4. We would get t to the 5 upon 5. So if we were to integrate t plus 1 to the power of 4, it's natural to expect it's going to be t plus 1 to the power of 5. Possibly over 5. We'll find out for sure, but for now we'll just make it t plus 1 to the 5 as our guess. So we'll try t plus 1 to the power of 5. That's what we're going to try. Plus c, of course. Okay, so we're going to differentiate that. So we want to find d by dt of t plus 1 to the power of 5, which is, if we differentiate that by the chain rule, we'll get the 5 coming out the front, multiplied by t plus 1 to the power of 4. As we differentiate, we drop the power by 1, and then times by the derivative of the inside of the bracket, which will give us a times 1 there. So this is going to be 5. T plus 1 to the power of 4 is the derivative of our trial. So we'll write that same statement the other way. If the derivative of this is that, then the integral of that is this. So that tells us that what we have so far is the integral of 5 times t plus 1 to the power of 4 dt equals t plus 1 to the power of 5 plus c. Now let's compare what we've got the integral of here with what we're actually trying to integrate, which is t plus 1 to the power of 4. So we've got the t plus 1 to the power of 4. The only thing is that we don't want this times 5, so we can get rid of the times 5 by dividing by 5. So we've got that the integral of t plus 1 to the 4 dt is t plus 1 to the 5 over 5 plus our constant. We have our answer there. Question B, we have the integral of 2t minus 6 to the 7th power. So what are we going to try here? We've got a bracket to the 7th power. When we integrate that, that power is going to increase. So we'll try 2t minus 6 to the 8th power. So we'll try 2t minus 6 to the power of 8. That's what we're going to try. Now we need to differentiate that. So d by dt is just saying derivative of 2t minus 6 to the power of 8. So we're saying the derivative of 2t minus 6 to the power of 8 is, now let's differentiate it. So 8 times that same bracket, drop that power by 1, so we get a power of 7, and then times by the derivative of the inside of that bracket, which is 2. So we get 16 times the bracket 2t minus 7 minus 6 to the power of 7. So far what we've got is our differentiation statement. Let's turn that into an integration statement. So we've got integral of 16 times 2t minus 6 to the power of 7 dt. That is what we tried, which was 2t minus 6 to the 8th power plus your constant. So we've got the 2t minus 6 to the power of 7 if we compare this integral with that integral. we've got the bracket. Only thing is that we don't want this times 16, so we can divide that by 16. Notice that c divided by 16, a constant divided by another constant, is still a constant, so we don't need to worry about dividing the c by 16. Okay, so we've got that the integral of 2t minus 6 to the power of 7 dt is 2t minus 6 to the power of 8 over 16 plus constant. Let's look at c, and we've got the integral of 4x times 2x squared plus 5 cubed, and we need to work out what the integral of that is going to be. The main part of the function here is that bracket. Notice that 4x is just the derivative of the inside of the bracket, which will come out by the chain rule once we do our differentiation. So the key part here is the bracket. So we'll try that bracket, 2x squared plus 5 to the power of 4. So we'll try 2x squared plus 5 to the power of 4. That's what we're going to try. Now we'll differentiate that. So d by dx of 2x squared plus 5 to the power of 4. So if we differentiate that, we get 4 multiplied by that bracket, which is 2x squared plus 5 to the third power times the derivative of the inside of that bracket, which is 4x. Okay, so let's write that in terms of an integral. So the integral of 4 times 2x squared plus 5, that's cubed, times 4x, is going to be, that will be what our trial solution is, which is 2x squared plus 5 to the 4th power plus your constant. Okay, so let's compare our integral here with what we're actually trying to integrate. We've got the 2x squared plus 5 cubed, we've got the 4x. Only thing is that we don't want this extra times 4, so let's divide both sides by 4. So that tells us that the integral of 2x squared plus 5 to the power of 3 times 4x with respect to x is 2x squared plus 5 to the 4th power divided by 4 plus the constant. Okay, question D, we have the integral of x cubed times the bracket x to the power of 4 minus 7 all to the power of negative 3. And we notice that if we differentiate this bracket, this x to the 4, then that is going to give us 4x to the power of 3, but it's only missing the number. We don't need to worry about that because this last bit, when we multiply or divide, is going to pick that up for us, so we don't need to worry about that missing 4. We need to therefore try that bracket, which is x to the 4 minus 7 to the power of, increase that power by 1, minus 3 plus 1 is negative 2, and your constant. So the derivative of what we're trying, x to the power of 4 minus 7 to the power of negative 2, is, if we differentiate that thing, we'll get a minus 2 times that bracket, x to the 4 minus 7 to the power of minus 3, multiply that by the derivative of the inside of the bracket, which is 4x to the power of 3, which is minus 8x cubed times x to the 4 minus 7 to the power of negative 3. Writing that as an integral, we have the integral of negative 8. What we got from the differentiation is negative 8x to the power of 3 times x to the 4 minus 7 to the power of minus 3 dx. That is our trial, which is x to the 4 minus 7 to the power of minus 2 plus constant, and compare our integral here with what we're actually trying to integrate originally, and we've got this extra minus 8 multiplier, which we can just divide through by. So this is going to be divide by minus 8, and we get that the integral of x cubed times x to the power of 4 minus 7 to the negative 3 with respect to x is x to the 4 minus 7 to the minus 2 over negative 8. Okay, so far so good. Now we have one last integral to tackle in this video. Here we've got the integral of, in one bracket we've got 3x squared minus 1. That bracket is multiplying into x to the power of 3 minus x minus 5 to the power of 4. And we need to figure out which bracket is the main one. And it's the second bracket for two reasons. Firstly, that bracket has a power, whereas the first one doesn't. Secondly, the first bracket is exactly the derivative of the second bracket. So the second bracket is the one where our trial solution will come from. So we're going to try that bracket, x to the 3 minus x minus 5 to the power of 5. And let's differentiate that. So d by dx of x to the power of 3 minus x minus 5 to the fifth power is going to be 5 comes out the front times the bracket as is, x to the power of 3 minus x minus 5 to the fourth power times the derivative of the inside of the bracket, x cubed differentiates to 3x squared minus x differentiates to negative 1. Okay, so we've got our differentiation statement. Reversing this into an integral statement, we've got the integral of 5 times x to the power of 3 minus x minus 5 to the power of 4 times 3x squared minus 1. That is the bracket, which is x cubed minus x minus 5 to the power of 5 over, we need to get rid of this 5, so we divide by 5 plus c, because now what we've got, once we've got rid of this 5, is exactly what we had to integrate to begin with. The brackets are in the other order, but that doesn't really matter because it's just a multiplication anyway. So we've got the 3x squared minus 1, and we've got the x cubed minus x minus 5. So what we have just found is that the integral of 3x squared minus 1 times x to the power of 3 minus x minus 5 to the power of 4 is x to the 3 minus x minus 5 to the 5 over 5 plus constant. Okay, thanks for watching. Over and out.